Okay, so we are going to look at some dimensional analysis practice. So I will be doing the problems the way that your textbook explains them in this railroad method. There are many ways to solve these problems, and you're never graded if you solve a different way. So this is the way that I will do it. So let's say we're going to convert 840 inches to decimeters. These are positive numbers. And I would tell you in this situation, or you would be given a table with conversion factors, that 1 inch is 2.54 centimeters. You would know that the conversion factor for centimeters to meters is that there are 1 times 10 to the second centimeters in a meter, or you could have said 1 meter is 1 times 10 to the negative 2 meters is 1 centimeter. Either way will work. And then from meters to decimeters, that 1 times 10 to the first decimeters is 1 meter. Or again, you could have said 1 times 10 to the negative 1 meters is 1 decimeter. So you can use either form of those. I'm going to write that down up here just because it sounds confusing. 1 meter equals 1 times 10 to the second centimeters, which is the same thing as saying, or 1 times 10 to the negative 2 meters equals 1 centimeter. These are the same thing. It's like saying $1 is 100 pennies. 1 penny is 1/100th of a dollar. It just depends which way you're going. So you could do either way here. I hope I'm not making it more complicated by explaining it more, but we're going to do a lot of examples. So I started with 840 inches, converted inches to centimeters. I want inches on the bottom, so they'll cancel. Centimeters on the top. So if I stopped at this point right here, my answer would be in centimeters. So now I'm going to go from centimeters to meters. So now I convert centimeters to meters by saying there are 1 times 10 to the positive second centimeters in 1 meter. And then I am going to cancel out centimeters. So now I have meters, and I want to convert meters to decimeters. 1 times 10 to the first decimeters in 1 meter. So now I'm going to multiply across the top and divide by what's on the bottom. So let's see. I'm going to say 840 times 2.54 times 1 times 10 to the first. Always make sure that you are putting parentheses around anything in scientific notation, because if not, it will just raise everything before that to that exponent. Divided by what's on the bottom, 1 times 1 times 10 to the second times 1, which is just 1 times 10 to the second. I get 213.36, and again, the unit is decimeters. So if this was the question I gave you, convert 840 inches to decimeters, and you gave me this answer, you would lose 1 point. Because even though the math is correct and the unit is correct, the significant figures is not. This number, 840, has 2 significant figures. 2, because this 0 is not significant at the end of a number with no decimal point. This has 2 significant figures. My answer needs to have 2 significant figures. So I look at the first 2 numbers, I look to the next one, it's less than 5. So my answer is going to be 210 decimeters. And that is the most correct answer. Okay, so let's look at another example. Let's look at an example where we are calculating, where we're changing 2 units at a time. So let's say I want to convert 41.7 miles per gallon to kilometers per liter. So this is a unit that has distance and volume, and I'm converting it to a different distance and a different volume. So there's 2 different conversions happening here. I would give you some of this information. So given in a table, or I would give you this in the question, I would tell you that 1 gallon equals 1 gallon is 0.2642 gallons is 1 liter. I would also give you that 1 kilometer equals 0.6214 miles. So this is given, and now we're going to convert both things at the same time. So I'm going to write this out. 41.7 miles, I'm just going to write miles, in 1 gallon. So two things are happening here. I want to convert miles to kilometers, and I want to convert gallons to liters. So miles to kilometers and gallons to liters. We can only do one at a time. So let's convert miles to kilometers first. So I know I want miles on the bottom and kilometers on the top. So here's my conversion factor. 1 kilometer is 0.6214 miles. So now miles has canceled. So if you were to solve the problem right now, your answer would be in a unit of kilometers per gallon, or miles per gallon, kilometers per gallon. So that's not the way we want it, because we want to convert to kilometers per liter. So now we want to convert gallons to liters. We don't want to touch kilometers. We're done with that. So gallons here is on the bottom. So here I want gallons on the top. So there's 0.2642 gallons in 1 liter. Now gallons are going to cancel. So now whatever this number ends up being, my unit is going to be kilometers per liter, which is what I wanted. So you can arrange this any way you want, making sure to cancel the unit you're trying to get out of and get into the unit that the question is asking. So we're just going to, again, multiply across the top, divide by what's on the bottom. So 41.7 times 1 times 0.2642 divided by 1 times 0.6214 times 1, and I get this number, 17.72954,619. I look at my question and I see how many significant figures I should have. I should have 3. So I look here, 1, 2, 3. The next number is a 2, so I am not going to round up. So my answer should be 17.7 kilometers per liter. And that would be full credit. Okay, let's look at one more. Let's say we are going to convert 32 feet per second to meters per minute. So I want you to convert 32 feet per second to meters per minute. Remember, meters is M, miles is MI. So maybe you should pause, see if you can set this up, and then see what you get. So I'm converting two things. First, I'm converting a unit of distance, and then I'm converting a unit of time. So you can do this however you want. 32 feet in 1 second. So I'm going to convert the distance first. I'm going to convert feet to meters. You would be given that conversion. 1 meter is 3.281 feet. So feet you want on the bottom. 3.281 feet in 1 meter. So now feet will cancel. So if you solved here, you would have meters per second. I want minutes. So seconds are on the bottom, so that means I want seconds on the top and minutes on the bottom. There are 60 seconds in 1 minute. Seconds cancel. Now my final answer is going to be in meters per minute. So same thing. I'm going to take 32 times 1 times 60, and I'm going to divide by 1 times 3.281 times 1. So I'm just going to divide by 3.281. And I'm going to think about how many significant figures my answer should have. My answer should have 2 significant figures. Remember, any of these conversion factors that you're given are exact numbers, so they do not contribute to the number of significant figures. So my answer should have 2 significant figures. My number is 585.187. So 585 with 2 significant figures, I'll write this down. 585.187. I want it to have 2 significant figures. 1, 2, and I look at this one, it's 5 or greater, so that means I need to round up. So that means it's 590 meters per minute. So we'll do some more of these practice. You'll see some in your SmartWorks. We also will see problems like this about specific chemistry topics that are coming up. This is dimensional analysis, and there's many ways to do this. Again, you do not have to do it the way that I do it or that your textbook does it, but I would revisit these later. Make sure you can solve these problems.